Hello viewers, today we'll be solving the IB Math AHL November 2024 paper 1 question number 8. You will be getting the other solved questions of this paper and the other papers in form of playlists on my channel NS Online Math Tutoring classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I am an online IB Math AHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve the question number 8. The maximum mark is 8. The following diagram shows 2 points A and B such that the vector OA is this position vector A and the vector OB is this position vector B. The point P lies on OAB so that the vector AP is lambda times the vector AB, where lambda is greater than 0 but is less than 1. Lambda is a fraction. Okay. So part A's question is show that the vector OP is equal to 1 minus lambda times the position vector A plus lambda times the position vector B. It is carrying just a single mark. So this is the vector OP and we have to prove this relation. So what is AB? First of all, because EP, we are saying this is OA because we will be taking the triangle OAP. So we are having this vector OA, that is the position vector of this point A. And what is EP? First of all, what is EP? EP is lambda times AB. So now my question is, what is EB? So we have to first of all answer this. What is the EB vector in terms of the position vector A and the position vector B? Okay, so EB vector is having this direction. So EB vector will be equal to the position vector B minus the position vector A. Okay, because this OA plus EB will be equal to OB. Okay, you are seeing the direction OA plus AB is equal to, this will be in the opposite direction, OB. Okay, so EB is equal to B minus C. And therefore, EP vector will be equal to lambda times EB, which is lambda times B minus A. Now, EP vector is in this direction. So, OE plus EP will be equal to OP. Okay, so OP vector will be equal to OE plus AP. OA is equal to the position vector E plus EP, that is lambda times B minus A. Okay, so this, if we expand this, open this bracket, it will be plus lambda B minus lambda A. So therefore, OP vector is equal to 1 minus lambda E plus lambda B. Okay. Shown. It is given that the magnitude of the vector E, position vector E, is 1 unit and the magnitude of the position vector B is 2 units, and the scalar product of the vectors A and B, A dot B, is equal to 1 over 4. Subpart B's question is, in the case that OP vector is perpendicular to EB vector, find the value of lambda. It is carrying 7 marks. Okay, so OP vector is perpendicular to the EB vector. Therefore, OP vector is perpendicular to the AB vector. Therefore, the dot product or the scalar product of the OP vector and the AB vector should be equal to 0. Okay. So what is OP vector? I'll be writing the expression for the OP vector first. 1 minus lambda times the A vector plus lambda B vector dot AB. What was AB? It was B minus A. Okay. This should be equal to 0. Now, we'll be just multiplying. 1 minus lambda times this A vector dot, there is the dot product, B vector. So, 1 minus lambda A dot B plus, okay, there is the minus sign, so minus 1 minus lambda A dot A plus lambda B dot B minus lambda B dot A. Okay, and we know the properties of dot products. From the properties of dot products, we know that A dot B is equal to B dot A. Okay, and also we know that A dot A will be what? A dot A will be equal to the magnitude of this A vector times the magnitude of this A vector times cos of the angle between these two vectors. These two are the same vectors, so the angle between them will be equal to 0. Cos of the angle between the two vectors, that is the dot product. So the angle between the two same vectors will be equal to 0 and cos 0 equal to 1. So A dot A will be equal to this. Similarly, B dot B will be equal to, okay. So now it is, let me just expand this part also. So this is 1 times A dot B. So I'm writing A dot B minus lambda times A dot B and there is another minus lambda times, it is B dot A, I'm writing A dot B. Okay. And this one is minus 1 minus lambda magnitude of the A vector square plus lambda magnitude of the B vector square. Okay. So A dot B is equal to 1 over 4. Okay. So 1 over 4 and this is minus lambda times 1 over 4 is minus lambda over 4 and this is also minus lambda over 4. I could have kept it like this, no problem. And this is minus 1 minus lambda and this is 1. Magnitude of the A vector is 1, so it is 1 square plus lambda. Magnitude of the B vector is 2, so it is 2 square. So these will be equal to 0. Okay. Fine. So it is 1 over 4 and I will be having this also. No, I have to separate. I had to separate. And this is minus 2 lambda over 4. So it will be minus lambda over 2. And this part is minus 1 times 1 is minus 1. and this is plus lambda and plus 4 lambda is equal to 0, and so 4 lambda plus 1 is 5 lambda minus half lambda is 4.5 lambda, okay, which is 9 over 2. So 9 over 2 lambda equal to 1 over 4 minus 1, which is minus 3 over 4. And if I add 3 over 4 to both the sides, we get equal to 3 over 4. Okay. So lambda, and now I am multiplying both sides by 2 over 9. So 2 over 9 equal to 1 over 6. Therefore, lambda equal to 1 over 6. Okay. So we have completed answering this question. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. It will be motivating me. It will be telling the YouTube that my video is worth watching. It will be increasing my video's reach. So that will be helping me a lot. We meet again very soon. In our next session, we'll be solving question number 9 of the same paper. Till then, bye.